Hi folks, we're going to take a look at number 4 from Unit 5, Lesson 5. So here we're solving this equation which now involves a tangent. Now keep in mind that tangent does not have a period of 2 pi. It has a period of pi, so that's going to come into play when we're solving this equation. And we also know that when we're working with tangent, it's not necessary to describe the answers using two statements. You can actually do it with one single statement. All right, so step number 1, this is still a linear trigonometric equation. So step number 1 is to isolate the trigonometric expression. So isolating tan of 2x minus 1. So here, what are we going to do? We're going to add 1 and divide by 2. So 6 plus 1 and then divided by 2. So we have tan of 2x minus 1 equal 7 over 2. So we have our single trigonometric expression equal to a number. So now we can use the inverse tangent function to solve for 2x minus 1. So that's tan inverse of 7 over 2. And so let's just calculate that here. Okay, so inverse tangent of 7 over 2 gives us 1.29. Okay. Now, because we're working with a tangent function, we don't need to find that second answer. It's going to come out naturally by using the period of the tangent function, which is half as large as that of the sine or cosine function. All right, so here I'm going to solve for x. So we're going to take this 1.29, I'll add 1 and divide by 2. So add 1 and then divide by 2. And so we have 1.15. Okay, and if I want to express all possible solutions, well, I know I have to just add or subtract multiples of the period. And what is the period of this function here? Well, the original period is pi, and I have to divide by my k value, which is 2. So my period is pi over 2, or approximately 1.57. So I can just add multiples of 1.57. And this actually gives me all possible solutions. Not what they were asking for, but I'm now going to use this to determine the solutions in the particular interval that they gave me. All right, so to give our final answer, well, x can be equal to, well, we already found 1.15. All right, and now I'm just going to start adding the periods. So 1.15 plus 1.57. So 1.15 plus 1.57 is equal to 2.72. Okay, so that'll be another solution. Now, if I try to add another 1.57, well, I end up with something that goes beyond my interval. Okay, but I'm also including some negative answers. So I'm going to take that 1.15 and I'm also going to subtract 1.57. Let's see what that gives us. 1.15 minus 1.57, and that gives us negative 0.42. So valid answer. Let's subtract another 1.57. Okay, negative 1.99. That's still good. Okay, but I believe when I try subtracting another 1.57, we get something that goes below my minimum value for my interval. So these are the 4 answers that solve this equation. All right, in fact, let's take a look at a graph to check that this is indeed correct. So I have this here. So by the way, notice what I did. I just took this 6 to the right-hand side. So I'm determining when something is equal to 0. That's always easier to do on Desmos. So if we check our answers, well, there's one of our answers, 1.15. There's another answer, our 2.72. But then 4.29 was too big. So we eliminated that. And then we went to the negatives. Negative 0.42 was one of our answers, and negative 1.99 was another answer. But this point here, it got too small. All right, so those are our 4 correct answers. Okay, so just to recap, with tangent, because it has a smaller period, and we know, again, remember if we draw this diagram, that tangent is equal, okay, for values that are separated by pi. So you don't need to have 2 separate expressions to determine all the answers for a tangent trig equation. So step number 1, isolate tangent. Step number 2, determine a solution using inverse tangent, and then from there add and subtract multiples of the period to determine all possible answers. And then here we determined which answers were valid for our range of values. All right, that's it for this one.